Okay. Today we're going to be doing a tech talk on scaling IoT for real-time insights. We're going to be using Redpanda, Iceberg, Profit, and AWS IoT. It's going to be a super fun session today. Brian, next slide. Today's speakers are Bryan Wood. He is a solutions engineer at Redpanda. Super great guy, super smart guy, and I'm excited to show you what he's been working on. And I'll be your MC today. I'm a developer advocate here at Redpanda. Um, so, uh, quick reminder, next slide. Please make sure to ask your questions early and often. Make sure to use the Q&A function, not chat. That way we can just kind of keep track of everything. As soon as you think of a question, go ahead and ask. Don't worry about waiting. We'll keep up with the list. We'll get through it at the end. And please keep your questions on topic. We can't answer detailed questions about your specific environment. Just keep it general and related to the presentation. I actually got to see this presentation live at Databricks back in early June when Brian gave it. It was super great, and he also had some really good questions during the presentation and after the presentation. So make sure you stay to the end of this webinar because I'm sure we're going to get even more great questions. And last thing from me, this presentation, next slide, uh, is recorded. You'll get a copy of all the slides, a link to the recording. We're also going to send you the blog post that this is based on, uh, and the repo as well. So make sure you stay to the end again. We're going to have a lot of fun. And without further ado, Brian, please take it away.
Thanks, Chandler. So, real quick, if you're not familiar with Redpanda, one of the things I want to do is kind of jump in and give you an overview. Of course, we're presenting a solution that kind of puts Redpanda center stage. And if you're not kind of aware of all the parts and pieces that we make available, the kind of whole architecture that I'm going to walk you through won't be quite as obvious why there's some really great advantages. So one of the core things to know about Redpanda is that we are a replacement. We're a complete end-to-end streaming platform. We do connectivity, we do brokers and clusters and streaming and topics and all those things. And at its core, right, the original thing when I started working here years ago that we did was we had a rewrite. We would tell it this way is that we essentially have a rewrite of Kafka. We've taken all of the things about Kafka that have not aged well. It's built in Java. It's actually kind of slow compared to modern standards. Um, and it leaves some performance things on the table. There's a handful of other things. It's really, really complicated. There's all these different parts and pieces that you have to run to make sure that it's all working perfectly. And so when our CEO and founder sat down, he decided to rewrite it from the ground up in C++ and also re-architect it. And so at the core, we have these brokers. You don't have all these external systems like Zookeeper or Cruise Control or an external schema registry or all these crazy parts and pieces. You just have brokers, which means it's really easy to run. And overall, since it's rewritten in C++ with a thread per core architecture, it's really fast. So there's its latency is far lower and far more predictable. On top of that, we have uh, some really great deployment options for you, right? We kind of end to end, we can also manage this in the cloud as part of our commercial offering. We can host it for you. We can also host it within your account using all of our automation tooling and stuff like that, where you have truly nothing to do. So you get a local inside of your cloud account set of brokers that are running super performant, as well as Redpanda Connect, our really massive connectivity suite, right? If you're not familiar with Redpanda Connect, essentially about a year ago, we acquired the project Benthos, and since then we've been pouring lots and lots of effort into developing it, adding more parts and pieces, making it more stable, making it more monitorable, things like that. Easier to monitor, I mean. But at the end of the day, really what it is we've got 300 connectors. They're all embedded into this single binary. You configure them with a snippet of brief section of YAML, and it makes it really, really easy to deploy these jobs that are going to reliably just pick up data from one place, maybe do some work on it, and send it on its way to the next to its location. You can do basic enrichment, you can do very basic windowing functions, You can do other little things with your data on the way as well. So introducing the project as a whole, or what the architecture as a whole, what we're talking about is obviously when it comes to these specific dynamics that we're going to cover here, Redpanda fits extremely well. It's durable and simple and scalable and all of these great things. So what I have is essentially a little prompt for us, right? As we're building an end-to-end IoT solution, we have a device, we have connectivity infrastructure, we have the need to do analysis, and we need a robust messaging platform and also a way to connect to our systems and do analysis. And then I don't know if you've ever been in the solution space. I have worked for an IoT company before. I've also just been in operations for a good portion of my career. I've been in tech for 20 years, most of the time on the builder side, right? In what I would call the customer seat now. But really, at the end of the day, there are always these big, often for good reasons, often for terrible reasons, top-down initiatives where you need to be able to scale to a whole bunch of devices, or you need to be able to scale to zero devices, right? And have just a tiny little pilot light of infrastructure. There's always this pressure to keep costs down. You need to predict the future. You need to reduce your code surface. In other words, make things more simple, deploy fewer services by making more elegant architecture decisions. Retain sovereignty of your data, right? Don't use a lot of offboard or external vendors and things like that to hang on to your data. Oh, and we also have to be cloud agnostic. We have to be able to put our stuff anywhere just because at some point maybe our cloud provider is going to jack up their prices, or we're going to have some business reasons, some big partnership we need to make, all those things. So uh, while we're building this architecture, these will be some of our considerations. And of course, I've crafted these considerations to this architecture that I like. Um, as you can see here, this is the very simple high-level architecture of what we're going to cover. Um, Essentially what we're going to look at, what we're going to do is I'm going to show you a brief little bit of code that will produce a message on an ESP32. I'll cover what that is in a little bit. That message is going to hit the AWS IoT stack via MQTT. We're going to pick up that message with Redpanda Connect. We're going to do a little bit of work on it, and then we're going to put it into a Redpanda topic that's running in our Redpanda BYOC offering. Then when we pick up that, once that message is there, our magical Iceberg integration is going to deliver that into an Iceberg table seamlessly. And then we're going to actually pick up that data and we're going to do a little bit of work on it. And what we're going to do is we're going to use the um, Meta's profit library, which you can use to do linear regression, which is essentially trying to predict the future based on past events. So, quick poll. Yeah.
Yeah. Um, so which IoT technologies do you work with today, and which IoT use cases are you most interested in? We're going to give everybody a couple of seconds to answer these before we move on. Personally, I have been experimenting with AWS IoT for like pretty recently. I've got this like weather station project that I'm working on. I've got this like crappy Amazon weather station that just like isn't working, and I was thinking it'd be fun to like build all of these components myself. So I've been doing some of that recently. Brian, have you been doing any other side projects aside from what you're about to get into?
With IoT, I will spoil a little bit of our the presentation later. Is there's other sensors that I want to add to this solution, and given how cheap this or economical this solution is, I would like to deploy a bazillion devices.
Nice. All right. Well, let's move on.
All right, thanks. Um, so as discussed, oops. Sorry, I just have to do some window management. There we go. Uh, as discussed before, the ESP32 is an economical and powerful system on a chip, or SoC. Uh, it has, I believe, a dual-core 32-bit processor. It's got a full Bluetooth and Wi-Fi stack on it. It's got some other really, really interesting tools available. And one of the things that I really like about it is I've built a lot of IoT solutions in the past where what you're building has an operating system, and that operating system requires a bunch of maintenance. And when your operating system requires a bunch of maintenance, you have to push patches for software that you're not really maintaining or you don't care about, or I mean, you care because you want it to work, but it's complicated. One of the neat things about these kind of smaller scale embedded SoCs, this is more like an Arduino, right? You can actually you can use the entire Arduino ecosystem to just push code onto the device rather than having to think about all this end-to-end management of an operating system. Now, on the other side is you don't get all of the bells and whistles that come with an operating system. For instance, you have to manage your own clock, things like that. Sorry, all the way down in the weeds there. The idea is that these things are a few bucks. You can get them on Amazon. You can order them in bulk. I have seen these in production scenarios, right, where people are deploying uh, tens of thousands of them, and it's great because they're economical. The development experience is great. The tooling that they make available, the interfaces with all the different sensors. There's a huge ecosystem of sensors out there that you can deploy, and of course, all types of pins and IO and things like that that you can do with it. Um, so here's a brief example of what that might look like. If you look in the project, right, I've pushed there's a repo, right, that's associated with this presentation. Um, if you look here, essentially what we're doing is you get two main functions here in C. This is C++. Unashamedly, in the last 6 months or so, ChatGPT writes the majority of these for me. It's a lot easier than remembering all my C++ syntax from a long time ago. Um, but you can see here that essentially these two functions, when the system boots up, it will run the setup function once, and then it will continue to run the loop function over and over and over, right, into perpetuity. So that's kind of your running function, and the setup is like, hey, let's get connected to Wi-Fi and do stuff. So what we're going to do here is we're actually at the end of the setup function. We're going to fall asleep and then reboot in 300 seconds. So the neat thing about this is we're going to start up, we're going to spin up the console. So if we wanted to connect to it, we could see what it's doing. We're going to set up Wi-Fi. We're essentially going to sync our clock before we start sending messages and negotiating TLS and things like that. Um, and then we're going to push the data that's coming from our sensor over to the MQTT stack that's in AWS, and then we're going to fall asleep and do it all over again. So I'm not using the loop because I want it to actually fall asleep and go into low power mode. You can get batteries that, with a configuration like this, you could last years, right, without having to recharge your batteries, because it's so low power, and then in low power mode, it consumes even less. So that's how we're going, and we're taking our sensors. We're essentially crafting a small JSON message, and we're sending it off to the AWS IoT stack via the MQTT protocol. And this is what those little messages look like. Essentially, just a device ID, the humidity in my office, the temperature in my office, the timestamp of exactly when, which is why syncing your clock matters, as well as negotiating with the endpoint. And then a UID for this specific transaction, just so you can tell it apart from the rest. Now, that message is sitting in MQTT. MQTT is a fantastic protocol for fan-in. You can connect thousands and thousands, if not millions of devices to a single endpoint. They can all be uniquely identified. They can all negotiate with their own certificates or a handful of other ways. Well, one of the things that it doesn't do well or at all is persistence. When a message gets produced to a topic in MQTT, if you're not there subscribing to it at that exact moment, it goes away and you have no access to it. It's not written to disk, which is why Redpanda or Kafka-based solutions in general, or streaming solutions are a great pairing. Now, when these messages hit these topics, we can pick them up and preserve them in a stream that has a retention window, right? We can say, hey, we're going to hang on to these events for an hour or a day or 7 days or a month or years. But you're hanging on to those events and you can reread them whenever you want. With Redpanda, we have the concept of tiered storage. So all of your data actually winds up being backed by an S3 compatible solution, which means you really can hang on to that data for just about however long you want without thinking about disks filling up on brokers. Um, Sorry, long explanation for with Redpanda Connect, it's really easy to pick up your messages off of your MQTT solution and essentially just deliver them here. You can see to a Redpanda topic. So very, very minimum of configuration. And I've seen people out in the wild. I've written this service myself out in production on IoT solutions that I've built where you have to go and write code that consumes from MQTT, and then you have to maybe do some work on that specific these messages as they're coming in, and then send them to a more permanent data store. These people write these bespoke services all the time, and you can absolutely replace those with essentially a brief little piece of YAML that does the same thing that everybody else is doing over and over and over. So high value here, reducing code surface, increasing simplicity. You can see here, this is just a screenshot from the Redpanda dashboard. Here's the message sitting in its topic, nice and happy, preserved, right, for as long as you want it to. And one of the neat things that you can see here is we get a bunch of metadata and information about your solution or about your message specifically. You can see I actually encoded this message in Avro. You can see that the key is text. If I wanted to compress it in the producer, I could have. Here we're seeing that it's uncompressed, and we're seeing the schema that it's being serialized against. So kind of a great dashboard, a great command center for making sure that all of your data is flowing. You can see that there's timestamps and stuff like that, so you can make sure that the data is fresh as it's moving along. If ever there's you're missing messages or data stops being produced, you can come in here and say, oh goodness, we haven't seen a message for a few minutes. What's going on? Now, data is sitting in the topic, but it's not an iceberg yet, right? If you go into that topic using our brand new, really amazing Iceberg integration, and you configure your Iceberg mode, right? We've got a couple of Iceberg modes. This is the most common. Essentially, what it's going to do is it's going to deserialize those messages and then reserialize them into Iceberg. And in 1 minute intervals, you can see here from the target lag, it's going to update that table with all of the messages that have been produced to that topic, which means now we have a magical table view of all of this data that's coming in. So this doesn't have to be just device telemetry. This could be, hey, what if you're sending messages back to a device that opens a door, pushes or enables something or turns on a light? You now have a count. Once this data is sitting in a table, you now have a count of all of the times that it has been turned on or off, or any of the other data that you've pushed out, or any times that devices have talked to each other via a topic. All of that data can come out, it can sit in a topic, and it can also be pushed to a table to be analyzed using your Iceberg provider of choice. Now, the neat thing is by default, we provide a very simple file-based catalog where you don't need any external infrastructure. That is in general being deprecated in the Iceberg spec. A REST-based catalog is the preference these days. And you should have that long term anyways. There's lots of open source ones. There are some fantastic vendors out there. We have really tight partnerships with both Snowflake and Databricks. I was just tinkering with the Unity catalog over in Databricks the other day. It's a pretty fantastic setup because they're also doing all of the table maintenance. That data that gets pushed into the table by Redpanda eventually needs to be kind of repartitioned, compressed, potentially vacuumed, things like that. And they're automatically doing all of that table maintenance. I don't even have to go in and like tell it to do a thing. It's automatically doing it as time goes on and optimizing based and repartitioning the data based on like read patterns and things like that. It's a pretty great solution. But overall, I guess, sorry, I should back up. If you're not familiar with Iceberg, Iceberg is a way, it's a spec for decoupling your storage for analytics, lakehouse kind of purposes from your query engine. Essentially, we're plopping your events and your data into S3 in a particular agreed upon format with metadata and all these different things and updating a catalog so that you can then come in and bring whatever query engine you want, right? You can write your own Spark jobs. You can use Databricks platform, right, to query your Iceberg tables. You can use Snowflake, And all of the data has the advantage of being in your account. So you can bring in multiple query engines, or you can choose different query engines. You can use different query engines based on what you find more favorable. So, sorry, I kind of explained that a little backwards there, but the idea is overall, Iceberg is a really, really fantastic thing that's growing ridiculously fast in the whole Lakehouse ecosystem solution space. And we're investing in it very heavily because of those reasons, right? It's very open, it's very sovereign, and it's also simple, and it's even getting simpler in a bunch of ways. So you can see here, I'm querying that data out of Iceberg. Here's just a little table view. I'm actually using our file-based implementation here, and I'm using DuckDB to query it because I didn't want to spin up a big old Spark cluster or do any of these crazy things. So it's really, really simple. I just pulled up DuckDB. The little Python snippet that I'm using is in the repo. But you can see here just regular old time series data coming from my sensor. My temperature is changing very little over time. My humidity is changing very little over time. But now that code brings all of our data into a data frame. And now that all of that data is in a data frame, uh, we can do some work on it, right? Now with Python, once your data is in a data frame, you can do all kinds of crazy operations and pivoting and training models and all types of wild things. One of my favorite things to do with time series data is I really, really like Profit as a solution, mostly because it's very, very, very simple. Back in the day, I took machine learning courses and things like that, and the solutions to do linear regression were very complicated. And there's nothing new about linear regression. It's been around a long time, but it has a lot of parts and pieces. Profit does quite a bit of automatic feature extraction and does seasonality and things like that. So that really, looking back, I'm just going to click back on our data just ever so briefly, right? Is essentially what we're looking for is, hey, given these timestamps and given the evolution of these values over time, um, keep drawing that line, right? Where do we think it's going to go based on previous values, right? That's all we're doing here. And it's really, really simple to say, hey, let's build a profit model. Let's pass the data frame into that model and essentially create the model, train the model, and then establish a time period that we would like to make our prediction over, and then make a forecast object that is essentially just the product of the prediction uh, function or method given that future object, and then draw a pretty picture, right? You can have it export this data to a CSV as well, right? Or however you want, right? So that you can put it back into some other table that gets read by some other solution. But I really, really like this for the simplicity that it provides. There's not a lot going on here. Also, I would say a lot of people when measuring accuracy of different approaches and things like that, this one isn't perfect. It's got its simplicity can also be a downside there. I'll talk through a couple of alternatives in a bit that are still regressive kind of approaches to predicting the future. So you can see here, this is the product. This is that picture that I told it to draw in that last line. Uh, you can see here that we've got the temperature kind of going up and down over time. I don't have good AC, so you can see that it's not very consistent. And the humidity is a little bit more consistent just because it fluctuates less over time. And what happened here on the evening of May 25th is I turned on a large box with a bunch of GPUs in it to do some fancy AI LLM learning and stuff like that. And you can see here that my measured humidity and temperature readings just went kind of crazy. And here's the model kind of trying to make sense of it over time. Essentially, the orange line is given the new regressive model, right, that it's predicting, here's how it predicts these values over time, and that's how it measures its own accuracy is against the real values themselves. But you can see once things kind of went wonky, it's kind of cool to see what it thinks these values are going to be in the future. It's saying, hey, given these, kind of crazy changes that you made, this is my best guess at, in a day, I think you're going to be right about here, and you're going to be right at about 29.3 degrees Celsius. So The other thing that we did not cover in that code example is that in this picture, I established these as co-regressors to each other, which means these values, the value of humidity and the value of temperature, are related, right? They have something to do with each other. So I told the model that, which means now that when it's drawing one line, that line can be informed by the values in the other, uh, in the other dimension, right? The other column. So the result, in short, is a low cost, obviously, right? Because it's scalable. There's, we're talking about very, very cheap hardware. We're talking about essentially just paying for your cloud provider costs plus Redpanda's licensing costs, um, as well as, the MQTT service. I believe AWS's MQTT service charges like a couple of bucks for every million messages or something like that. There's other great MQTT solutions out there as well. It's durable. I didn't cover this really, but Redpanda is the most durable broker out there that you can get. You can drop brokers and not lose messages, and that's a bold statement compared to other streaming services that are out there. We have data sovereignty as we discussed. Your brokers are in your account. Your storage is in your account. Your Iceberg tables are in your account. It's simple. There's very little code, right, that we've looked at throughout the course of it. Probably the producer code on the device was the only part that, requires a little bit of domain expertise. And all of these things have SLAs, right? AWS has SLAs, Redpanda has SLAs, all of the great Iceberg providers out there, the query engines and all those things, they have great support agreements and things like that. So this is a pretty solid solution in my mind, and it didn't cost $1 million, which I think is a pretty cool, and again with the scalability, this could truly support, thousands and tens of thousands and millions of devices, given some minor tweaks and things like that to adjust for throughput and stuff. But overall, right, all of these technologies scale extremely well. So in the future, and we'll ask a question on this. So if you have any questions or would like to see more, I would love feedback. So either reach out to me or answer in this poll that we're going to have. I want to know if there's any other things that you'd like to see or talk about, because this is a pretty fun, um, excuse me, this is a pretty fun solution. I like it. I made this in my spare time. It's like I said, it's running on my desk. I even have one here. Well, I guess I'm not sharing my screen, but you can see it on my camera. Uh, this is a fun solution. There's a bunch of other things I'd like to continue covering, so I'd love feedback sometime. Um, I want to add more data. I want more sensors. There's all kinds of crazy stuff that you can get. One of the ones that I've been working on is barometric pressure. That's a really, really interesting indicator if you want to predict the future. Barometric pressure increases and decreases over here can impact wind speed and of course temperature, right, in some other location. So I would love to add more devices and add barometric pressure and see how accurate I can get on the whole prediction of weather, which would be really fun. Um, uh, and I, of course, use these things as co-regressors, right, to inform each other. Now, one of the failings, right, in Prophet's simplicity is its co-regressive capabilities are limited. And so there's other tools that do a better job of being informed by co-regressors, make more accurate predictions, allow you to feed in other co-regressors or other features that may be even more interesting. And probably the one that I really want to focus on someday is temporal fusion transformers or TFTs. This is where you unlock and you go massively parallel in the way that you're training your model. And also, it won't just take, you can configure it to not just take other information as co-regressors. It will actually establish leading indicators from other pieces of data. So if you've got a barometric measurement from that you think is going to impact from a different device that you think is going to impact the temperature of this other device, it's going to actually go in, it's going to weigh it, it's going to say, hey, actually, yeah, it tends to be that in 2 hours ago or an hour ago or 15 minutes or whatever, it'll automatically figure that out and say, hey, over the course of time, this has been a very reliable predictive indicator of this value over here. And it's a pretty cool new thing. And being able to train it in parallel means you can consider a very massive amount of parallel features. So sorry, that's all the way in the weeds on what I think is really cool about predicting the future and where we're at, right, in the ML world. on different regressive approaches. So, like I said, I'd love any thoughts or feedback that anybody has on the subject. And kind of a parting shot here is, of course, I showed AWS IoT. It's one of the easier ones to get started with. We have super tight partnerships with MQTT providers out in the field. Mosquito is one of the open source ones. You can go and stand up your own Mosquito servers for free. HiveMQ has a super strong community. Zilla has Acclivity's Zilla product has a really fantastic approach for like a tight coupling between an MQTT provider and a Kafka-like streaming service, right? And we have a really tight partnership with them. So all of these work. They're all fantastic. There's other MQTT providers out there that I haven't mentioned. But I just didn't want anybody to think that, our integrations are, limited to what AWS provides, because MQTT is a fantastic solution that's out there. It's durable. Like I said, it supports a humongous amount of devices, all reporting into a single place, and we have extremely complementary features.
Sweet. So we have a poll open right now. If we hosted a part two of this talk, what topics would you like us to cover? If you haven't already, please take a moment, answer this. It's super helpful. Bryan wants to share more, and he just needs to share or know what to share more about. And now we're going to go into a little Q&A. Again, if you have questions, please post them in the Q&A. If we don't get to your question, we'll follow up after, of course. Bryan, next slide, if you don't mind. Assuming sensors are in multiple buildings and each message contains a building ID, is there an easy way to split data by building ID into multiple Iceberg tables or namespaces from a single IoT Kafka topic? With Redpanda Connect, you can actually create processors to split and manage data streams. It's actually a really neat feature. Bryan just kind of showed the input and output, but you can actually add a third step there. And you can do other things too, like if you're streaming customer data and you have like social security numbers and you want to redact them, you can filter that out in the same place. I recently just posted a short YouTube video, it's like 60 seconds long, where I'm pulling data from S3 and actually manipulating that in flight to strip data. It's pretty neat. Bryan, do you have anything to add for that?
No, that's exactly what I was going to say is, as your data, whatever MQTT server it hits, right? Maybe each building has its own or whatever. That doesn't matter a ton, because you can reliably pick up those messages from each building and funnel them into the same topic, into different topics. It kind of doesn't matter, but using that processing layer that's in the middle to do that initial amount of filtering, if you say, hey, I want this data in different Iceberg tables, that means you would want to route it into a different topic. The topics are the tables. There's a direct mapping. When you create a topic and you configure it as an Iceberg table, it automatically shows up in your catalog as, as with the exact same name. So that's how you would handle that on the front side. But if you wanted to even split your data by a different dimension and say, well, these devices from, maybe I want all of my light switches or my light bulb, my smart light bulbs or something like that to show up in their own topic, regardless of building ID. Or, if you don't want to get too crazy, but if you wanted all of your light bulbs in this building to even be in their own topic, you can make all of those decisions in the processing layer and then push it to the appropriate topic. One of the things that I have noticed is it can get really complicated because MQTT topic structure is nested, and obviously Kafka-like topic structures are not. And so one of the little tricks that I tend to do, uh, that it's not perfect, uh, but I will stuff a lot of times. I will create a more generic schema, and I will take the topic name from the MQTT side, and I will import it in the processing layer inside of the object that I'm delivering, inside of the message that I'm delivering, and push it on its way, so that I can have maybe like a big general receiving topic where all of my messages kind of funnel into, and then I can write another Redpanda Connect job that's actually going to do some really advanced filtering. But I get that kind of early persistence layer and a little bit of relief in my mind, where kind of all of my stuff winds up hitting one spot, and then I can filter it based on the actual topic later into other topics. This generates a lot more traffic, more load on your cluster. So of course, if you have a ridiculous amount of scale or something like that, it's a thing to consider, but it's also a simple thing you could do. Um, Also, look into Redpanda transforms. I'm not going to go all the way into the weeds on this, but we do have an ability to filter and sort and move messages around on the broker itself extremely quickly. It'll reduce your load. It'll be a lot faster. You won't have to go, you'll essentially, you don't have any access to the network or any of those things. You can push very, very simple functions that will be executed on your broker. And then as a result of those, you can push them into different topics. So feel free to reach out to us or me, and happy to explain that in greater detail because that's a whole rabbit hole in and of itself, rabbit trail.
Yeah, so the short answer is yes, and a whole lot more as well.
Right.
Yeah, next question. What kind of latency would you expect for querying this data in Iceberg?
That's great. So latency would be the product of course, your query engine and the flush interval. I believe by default, I can't remember, it's either 1 or 10 minutes, but the flush interval, it's configurable down to a minute, I believe. So that's probably the closest you can do. Is essentially because you're asking the exact right question, is this data has to be batched up. Since we're writing it to S3, you wouldn't write individual messages to S3 if you've got megabytes per second of individual like 1K messages. You're gonna just it's that would be a poor choice and a poor architecture. So yes, each one of your leaders of your partition on your brokers are going to be batching up this data and stuffing it into S3 in Iceberg format with a flush interval of a minute, a minimum flush interval of about a minute. I don't think you can tune it any lower than that. Like I said, I think the default is 10. But if you're using like Unity Catalog or something like that, they're going to automatically optimize and repartition your data. So at a fairly minimal cost, they're going to, if you're worried about writing small batches and having to read all those small batches, right, from your query engine, they're actually going to repartition that data for you very, very quickly anyways. So it's not a humongous tax to have a small flush interval. Sorry if that's a hyper technical answer, but the flush interval essentially is what decides that.
Well, it is Ask the Expert, right, Brian? Um,
Expert might be generous.
so the first question we had has a follow-up. He also says, thank you for the answer. If I had thousands of buildings, is the topic per building still viable?
So, we have really, really great documentation. The implications on our side, on the Red Panda side, um, are we have a number of connections that each cluster can support, and there is a number of partitions that each cluster can support, and an amount of ingress and egress. So if you're building your own cluster, if you're out in the community and you're just using Redpanda, then we have a scaling guide that will tell you, hey, this much processor and this much memory, this many processors, this much memory, rough guidance, no promises, will get you a performance profile roughly like this, right? They're rough guidelines on scaling. But the trick is that partitions take up memory and throughput takes up processing and egress and ingress and disk I/O and all these things. And so as long as your cluster can support the number of partitions that your proposed architecture supports, in other words, you can produce to as many topics as you want as long as you have a cluster that's large enough to do so. Um, you can see the limits of our managed solution. So we sell clusters in essentially tiers. So tier one is like, I think, 20 megabytes of ingress and 60 megabytes of egress and a certain number of partitions that it supports. As long as you can, as long as what you're proposing, right, from a number of buildings perspective, and buildings to topics mapping makes sense, and can be supported by that number, that's your main concern or dynamic there. Um, we on the Red Panda side in the solutions engineering organization, we are very concerned with scaling and scaling our customers and stuff like that. And so we're happy to dive all the way into the weeds with you on that particular subject if you have a use case.
Awesome. Great answer, Brian. Before I move on, if you do have a question, make sure you post it in the Q&A before we wrap up. And this is related to the tail end of your previous answer, but I am new to Redpanda. How much configuration, fine-tuning is required compared to running a Kafka cluster?
That's like it's a fantastic question. It's one of our favorites because Red Panda is so much easier. Uh, Kafka, if you're going to deploy it, get ready. It's intense, right? You've got Zookeeper or KRaft as a separate system that's used to manage to appoint leaders amongst partition groups. Um, you have to think about ISR for replication in the background. You have a concept of brokers, which is a separate thing that you have to manage. All of these services are in Java, which means you have to tune JVMs and things like that. You should probably have cruise control to move your brokers around, or sorry, to move your partitions amongst your brokers when they get too busy. You'll need a schema registry. Not need. You may need a schema registry, which is a separate thing. In Redpanda, it's built in. Maybe you need an HTTP proxy. We have one built in. Otherwise, anyways, sorry, on and on and on and on. If you want to go and do a Docker Compose up on our quick start guide, you'll have a Redpanda solution up and running, and the only two things that it's going to deploy are brokers in a console. There's some other like other services that it'll deploy to like produce data and things like that, but the Redpanda solution itself is brokers and a GUI. And so getting started is much easier. Deploying it, right? If you look at our Helm charts and our Ansible playbooks and all those things, they're much simpler because really all we're doing is pushing a single binary out there, which is easy to containerize, and we're configuring it with a couple of pieces of YAML. Our RPK is our command line that you would use to configure these clusters. All of that to me is very sane and straightforward and requires far less operational overhead. And I don't know if anybody else out there has had to run Kafka clusters in production. Yes, there's managed solutions that are out there. They simplify it to a particular degree. I used to work for a company that had an event uh, that where Kafka went down, and it went down from time to time. We could usually fix it pretty quick. Our CEO likes to call it distributed systems whack-a-mole. You got to go and, oh, are things being serialized or deserialized improperly? Oh, let's go check and see if the schema registry is on. Oh, are they all losing their brains in one degree or another? You better go check, Zookeeper or KRaft or whatever. This place that I worked at had a major outage that impacted customers and all these things, and it went on for a good long time. And so they called it the Kafka Thunderdome, and they handed out trophies for people who worked on it. And so this is what I carried forward moving into working at Redpanda, the place that solves all of those complexity issues. Genuinely, it's a pleasure to run. That's what we hear from our customers. I've never heard of anybody going from Kafka to Redpanda and hearing that it's a worse experience, even from managed services to managing them themselves. Um, it's 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 that also impacts its reliability. It makes it an easier system to run, is more stable. Um, sorry, all the way in the weeds again.
Oh, good, Brian. Don't forget, if you haven't already, please answer our second poll so we can know what to cover next. Another question. If you could build this again, what would you have done differently?
Ooh, that's a good question. So I carry with me a great deal of IoT solutions experience. The first time I built something, I had to write that service that sync things from MQTT to different data stores, and I did not have a streaming platform in between. It was a serverless architecture, which actually wound up being expensive at scale. So actually learning many of those lessons are what brought me into build out an architecture like this, even though I'm not working for a company that's directly building IoT solutions. I wanted to right a bunch of wrongs that I had done in my past. So looking forward, if I were to change something, we did cover a little bit of it. I would like to add a lot more data. I would like to add a bidirectional concept. It's just as easy to take all of the data, to take data that is produced to a Redpanda topic internally and have Redpanda Connect pick it up and push it to an MQTT topic where a device can pick it up and, turn on a light or something like that. Um, I would like to enable that bidirectional functionality, and of course have more dynamics, right? Devices should be able to talk to each other over MQTT. All of that information should proliferate down into a topic structure on the Kafka side, on the Redpanda side. So really, if I were going to do it again, it's just add more features to make it more like real life scenarios that I've had to manage in the past. Um, I think probably if I was going to show another example, I would show our Databricks integration as well. Like that's, this example that I have here is using our file-based catalog. Databricks is like next level on data analysis and also Iceberg topic maintenance and all these things. They made a bunch of great announcements and announced our partnership with them in June, like Chandler was saying at the Databricks Summit. They're investing heavily in Iceberg, and their experience is really great. I've been learning a lot about it lately. So that might be the next incarnation, as well as, a lot of the Python code. I can run it in one of their notebooks and just show you the results live. Maybe I'll do a live demo as well.
Awesome. What else is Red Panda doing in the IoT space?
Oh man. What else is Redpanda doing in the IoT space? Uh, I would say there's a handful of major architectures that we support. We support all architectures from different perspectives. This one is great for like smart buildings. We didn't really cover edge computing, and I would say edge computing, on-premise edge, things like that. That's probably, I would say, even more popular than the use cases we're going over here. I'm kind of illustrating a point of bazillions of devices and organizing your data in a particular way and having access to that in a queryable way. I would say the real boots on the ground implementations that I'm seeing our customers do right now: warehouses, manufacturing, um, other things, right, where there's actually very likely an on-premise Red Panda cluster that they're managing, right, on in racks, and then they're having Connect kind of be a middleware that, so many of these devices, they speak some really bespoke protocol that makes sense to, embedded engineers who are managing lathes or CNC machines or something like that. But it's spitting out some type of binary protocol, right? And so that's what I'm seeing a lot of is Red Panda plays a huge role in the ability to ingest that data at very high frequency, right? We're the fastest, we're the lowest latency. We are absolutely able to stand up to very, very low latency requirements, as well as very, very high throughput requirements. So these devices are spitting out tons and tons of information, or warehouses as well, at maybe a slightly lower frequency. Um, I'd say those are our biggest like boots on the ground actual IoT solutions that we're seeing spin up. There's plenty of smart home and smart office kind of applications as well. Um, but I would say that's the other kind of architecture that I see us just absolutely taking off on. And those that actually may be our highest. I don't know that I can say who the customer is, but that would probably be our highest throughput use case ever at Red Panda. I can say would be the manufacturing level one.
Nice. Uh, with diskless Kafka gaining traction, is a similar feature planned for Red Panda? And do you think something like that would help lower deployment costs?
It does to a degree. One of the biggest things that diskless helps you manage is your multi-AZ transfer costs. It doesn't manage uh, it doesn't reduce your costs. Like the only other variable is that like whoever provides that solution charges more or less, right? A huge portion of that is you're saying, hey, I'm willing to wait a little bit for my message to show up on the consumer side if you batch it and stuff it into a disk, right? So a diskless solution is made to kind of overcome that one major obstacle. um, Red Panda Connect has, or sorry, Red Panda has a solution that we're working on, and it's going to be a feature of, and I can't say when, right? We'd have to go talk to a product manager and stuff like that. But it's going to be a feature. It's not going to be a completely separate product. I think the biggest failing of this offering in other areas is that you have to purchase this as a separate product. For us, it's just going to be a feature. If you want diskless topics, right, where you're willing to wait a little bit for your data to show up, what we see is that, well, you should be able to configure that as a topic property, and then just say, okay, now this is the one that's a little slow, but it's cheaper, and you can configure topic by topic per solution, right? Most of the other places where you can get diskless deployments, it's a completely separate thing. You have to deploy them in completely separate ways. Your data will live in completely separate places. One is with the provider and one is in your own cloud account. I mean, it gets really, really complicated if you want to do both. And I think the vast majority of our customers have the ultra low latency requirements, the inter-service communication and things like that, where you can't wait even a few seconds, right, for a message to go from one service to another. You have to have the low latency use case. And then for the stuff that you can wait for, they want to divide up those workloads. Most of the people who approach us, even if they have a tolerance for a higher latency, it's not for all of their workloads, it's for some. So that's how I see it, right? Don't take that as the official Red Panda answer. But I that's what I see is the vast majority of customers are uh, kind of willing to wait for that feature, and when it comes out, it'll just be a way to help them lower their bill, you know.
Awesome. Great answer, Brian. So we're running short on time, so we're going to take one more question. But if we didn't get to your question, we'll follow up. And if you think of a question later, you can message us on LinkedIn. You can also contact us by email. For both of us, it's first name, last name at redpanda.com. We really don't mind. And we will share the slides after the end of this presentation, as well as the link to Brian's blog post and any other resources that we have. So final question. Can Redpanda Connect help with stateful transformations? For example, a 10-minute window of averages of temperature. The answer is absolutely yes. Brian?
I'm gonna actually you there. So yes, aggregating over a 10-minute window is for us a stateless operation because you could reread those commits and rebuild that window. Uh, that being said, that is a place where Red Panda Connect may not be your full-blown end-to-end transformation solution. It's great for SM single message transforms. It's great for small amounts of math, reorganizing individual messages and things like that. Yes, we absolutely can do a 10-minute window and things like that. Just recognizing that, let's say you lose the connect thread, right, that's running that job, that it's going to have to go back and reread that window from the last offset that it committed and kind of replay it, rebuild the window and move on. So yes, we can do it, but I'm very hesitant to say this is going to be your replacement for Flink, right, or your end-to-end stateful transformation tool, because we have people who do want to do a certain amount of like, hey, I want to keep a cache of information from this topic running so that I can go and enrich my other topic with it and stuff like that. There's other solutions. I've seen people solve these problems in different ways. I've seen them use Red Panda Connect to hydrate a cache from one topic and then query it from another. But don't think of us as the feature complete replacement for these highly stateful tools that are out there. Yes, we can totally do a 10-minute windowing function. But sorry, the answer is, reach out to us and we love to talk through architectural subtleties and things like that. Um, yeah, thanks, Chandler.
Yeah. And this is why it's important to have the expert on, because thank you for adding the additional details there, Brian.
Yeah, the answer is both. We absolutely can do that. It's the highly stateful operations that I don't want to oversell our solution on.
Yeah, which is a great point. There's more to that than just the surface level, of course. So we're going to go ahead and wrap up. We can go to the next slide, Brian. Share some resources. So if you want to keep learning, Brian has put together a great blog post on this talk. Uh, it's a really great read. Make sure you take the time to check it out. We'll also follow up and send this in an email. And if you want to learn more about Red Panda, next slide. We've got a couple of other resources as well. We have Redpanda University, where you can take your own self-paced course. We have our docs, of course. We have our Slack community. Make sure you join our Slack community and ask us questions there. We have a bunch of other blogs as well if you're interested in other topics, including more things related to IoT. We have a great we have a great GitHub of like tons of different repos of examples. And when you're ready to try Redpanda, you should check out serverless. Don't need to deploy anything. You can just create an account and start playing right away, including with Redpanda Connect. And last but not least, next slide. Thank you for joining. Follow us on, all of the socials. Reach out to us. Please keep in touch. Again, you can reach either Brian or I on LinkedIn. You can send us an email at first name, last name at redpanda.com. Thanks so much for joining and watching our presentation.
Thanks, everyone. Thanks, Chandler.